x. We know that that's an exponential decay function. So exponential decay function is going to look sort of like this. We know that if we plugged in x equals 0, we'd have e to the 0, which is 1, etc. Okay, now we're going to look on this interval out to natural log of 6, so we're just going to call that natural log of 6 right there. And we are going to rotate around that line, and the region that we're rotating is going to be all of this. And that's going to create a solid object. So we're taking the area that's the region that's between e to the negative x and the x-axis on that interval. So that whole quantity there. And then we're going to rotate it around the line x equals natural log of 6. So we're going to get a bowl-looking object. We are going to use integration by, we're going to use shells. We are going to use integration with shell method. So I'm going to draw a vertical element. That vertical integration element is at a random x, and it is parallel to the axis of rotation. We need it to be parallel to the axis of rotation in order to create a cylinder. The height of the cylinder is going to be that, and then the radius of the cylinder is going to be this distance from there over to there. That is the radius. And that radius is a horizontal distance, which we will find in one moment. So the area of our shell generically is 2 pi r, which is the circumference, times the height. So 2 pi r will be converted into 2 pi times r, which is a horizontal distance. Horizontal distances are found by doing the right minus the left x value. So the right x value is ln6, the left x value is called x. So that distance right there is ln6 minus x. And then the height is the function, e to the negative x. All right, so there is our generic formula for the area of a shell. We now can integrate this to get volume. So we are going to have, let's do a little bit of distribution or factoring here. So we're going to have 2 pi out in front, and then we're going to have the integral from 0 to natural log of 6. And we are going to distribute, so we're going to have natural log of 6 multiplied by e to the negative x minus x times e to the negative x. We are going to now turn this into two separate integrals. So we're going to have 2 pi all the way out in front. And we will have the definite integral from 0 to natural log of 6 of natural log of 6. I guess I could have factored that out. We'll do it in a moment. Minus the integral 0 natural log of 6 x e to the negative x dx. So that first integral is going to be done immediately, directly. It's an integral of an exponential, no problem. The second one, we need integration by parts. So let's come over here to the side. We're going to let u be x. We're going to let dv be e to the negative x. And so when we complete our integration by parts table, we have that du is equal to dx, and v will be e to the negative x divided by negative 1. So we get negative e to the negative x. That gives us, let's see, so 2 pi bracket. This integral we can do immediately. The integral of e to the negative x is itself divided by negative 1. That's going to get evaluated, 0 to natural log of 6. And then this one becomes minus, and I didn't push this minus sign in, so we have to be careful to distribute it amongst our uv minus integral of e to u. So uv is negative, and when we distribute this negative to it, we get negative times negative, which is positive, x e to the negative x. And then we're subtracting off v du. Now, we're subtracting off v du, but this minus here means we're adding v du. But then when we look at v du is negative. So we're going to have minus integral e to the minus x dx from 0 to ln 6. Have that. Let's close those brackets. So let's go ahead and evaluate this first part. When we plug in ln 6, we are going to have minus natural log of 6 e to the minus natural log of 6. And then we subtract off what we get when we plug in 0. E to the 0 is 1, so we're going to have minus a minus, which is plus ln 6 times 1. All right. And I forgot the little evaluation bar right here. We need this piece has to be evaluated also when we're dealing with a definite integral. So we can go ahead and do that right now too. If we plug in the natural log of 6, we get natural log of 6 times e to the minus natural log of 6. And then we subtract off what we get when we plug in 0 in there. Well, plugging in 0 for this coefficient is going to give us 0. So that's 0. And then we can integrate this last integral. We get minus the integral of an exponential is itself, divide by the derivative of the exponent, so divide by -1. We get that. And then that's going to be 0 to natural log of 6. Bracket. All right, we're almost there. So this 2 pi we'll just deal with that later. Bracket. So there's a little simplification that can happen here. So we have minus natural log of 6. This coefficient can come up as an exponent. 6 to the -1 is 1/6. And remember that the e and the natural log will cancel each other out, getting whatever this coefficient is, or whatever this constant is in here, which is 6 to the -1, which is 1/6. So plus natural log of 6 plus, similarly here, we have natural log of 6. And then this negative right here, once again, is going to fly up into the exponent position, giving us 1/6. The e and the ln will cancel, so we get that. And then we're here, and we have e to the minus natural log of 6. And there's another one of them. Minus e to the 0, which is 1. Okay. Now we notice that, hey, there's a negative one of these and a positive one of those. So those are going to cancel. So we will have 2 pi natural log of 6 from here. And then we have the -1 from the end. Now we have to deal with this thing. And once again, the minus comes up into the exponent position, giving us 1/6 on the inside. So we're going to have a plus 1/6. And our final answer will be 2 pi multiplied by ln 6. We can combine those terms, and we will get minus 5/6. And that will be our final answer.